Example number 2 is with variation. It says that the time taken to build a house is directly proportional to the number of houses. Pause. Directly proportional. That is y equals kx. So step 1, when you see directly proportional, underline it and write your formula. Now this is time taken is directly proportional to number of houses. So y is the time and x is the number of houses. It's important to keep these things straight. So I've stopped here and I've already established that whole sentence and encapsulated it in a small amount of information. So you don't have to reread the problem a bunch of times. This is a very important step. It says on the estate and inversely proportional. Oh, interesting. If it was y was inversely proportional to this, then we would have k over that thing. So when you have it both, when it's directly proportional to one thing, but inversely proportional to another, you can put it in one big equation that looks like that. And that thing that it's inversely proportional to is the number of builders. I'm going to pause and I'm going to try and make sense of this. That as number of houses goes up, time also goes up, right? That's what directly proportional means, is as one goes up, the other one also goes up. And so, okay, as number of houses go up, the more houses I have to build, the more time it's going to take. Yeah, that makes sense. Versus the number of builders I have. If the number of builders I have goes up, then the time it's going to take is going to go down, right? The more people I have, many hands make quick work, right? The more people I have, the less time it's going to take because we're all working on it. So that's inversely proportional with time. Oh, okay. Yeah, that makes sense. Grounding yourself in the problem to be like, what is the relationship here that we're talking about is important to kind of like move on and make sure that at the very end, when you're assessing your answer, that you're like, yeah, that makes sense in the context of this problem. So you can always check to see, did I do this correctly? If it takes 7 builders 7 days to build 7 houses, how long will it take 2 builders to build 2 houses? A lot of information. I'm going to have time be equal to T, number of houses be equal to H, and builders be equal to B. And then I'm going to say, okay, well, if it takes 7 builders 7 days to build 7 houses, interesting. Okay. It says, how long will it take? So, how long is a question mark, time is a question mark, to take 2 builders, so 2 builders, 2 houses. So, I'm given some information, and then I want to find some information. So, I've just taken all of that information now and encapsulated it in a quick and easy to read format. And this is the format that like I created when I was, trying to problem solve. But if you have a different format for writing down this information, then feel free to follow your own format. You don't have to follow mine. But this idea of like, how can you quickly jot down all of the information so that way you don't have to reread the problem a bunch of times. So as always with our direct and indirect variation problems, we need to make sure that we are finding K first. So that's going to be a big overarching question mark that we have to get out of the way first, which we have things that we can plug in for X, Y, and Z, which is now T, H, and B, in order to solve for K, because we know K is actually supposed to be a number in this case. It's hard to remember with all of these variables going on what's supposed to be a number and what's not supposed to be a number, but this guy's definitely supposed to be a number. So I plug in all of these variables to solve for K. Seven days, 7 houses, 7 builders. Those 7s cancel out, and I'm left with K being equal to 7. So my formula now is T equals, and instead of K, I have 7 times H over B. Time is directly proportional to the number of houses, but inversely proportional to the number of builders. And now I know just how that's all related, that this guy is 7. So now that I've solved for K, I can solve for T. T equals 7 times number of houses, which in this case now is 2, divided by the number of builders. So how much time is it going to take? Those 2's cancel out, right? Or in other words, it becomes 14 divided by 2. It takes 7 days for 2 builders to build 2 houses. And that is your answer. So formula-based modeling with direct and inverse variation, you start off with the formula like always. This one, it doesn't matter whether we have 1 or 2 inputs because we're not asked to graph anything. This technically has 2 inputs, H and B, with an output of time. And that's fine because we aren't asked to find a minimum. We aren't asked to find anything else. And we're given the 2 values for 2 of those inputs so we can find the output, right? So all of this is fine here as long as we're not asked to do anything that requires us to graph. If we need to graph, that's where we need to have only 1 input. Okay, last problem. This is your system of equations problem, and it's going to take just a little bit of time because we've got not nice numbers, and with systems of equations with cubics, because it's going to tell us to develop a cubic model, we have to make 4 equations. So it's just going to take some time. But it says that the distance from the sun in astronomical units and the orbital period in Earth years of 4 planets in the solar system is given below. From this data, form a cubic model to predict the orbital period from a planet's distance from the sun. So if orbital period is kind of like our y, which is t, and distance is kind of like our x, which we're going to use d. We want to, first of all, we're going to give the coefficients to 3 significant figures, which means all of our answers are going to be 3 sig figs. We want to find a cubic model. And if it gives us a table is just points. Whenever you see a table provided to you in a problem, that is your first hint here that it's going to be a system of equations. Why? Because a table is just a fancy way of presenting points to you. And if we have a bunch of points, then that means we're making a bunch of equations that involve A, B, C, and D. That time as a relation of distance is going to be equal to A times distance cubed plus B times distance squared plus C times distance plus D, which is different than this D. So maybe I should call it X for right now until we get to our final answer. Just for clarity. Okay, so we have 4 unknowns, A, B, C, and D. We have 4 points, Venus, Mars, Saturn, Neptune. These are all points. So now I can just take these values and plug them in. Something I've seen in classes, sometimes we're still struggling with figuring out how do we plug it in. But remember that 0.615 is T. So I just replace T with 0.615 equals A times, and that cube is only being applied to X, not to A. So I plug in this X value here, 0.723 cubed. You can even put that cubed inside of the parentheses. And you do the same thing with this guy, except for now it's squared. And you can leave it like that. You don't have to figure out what that is cubed because you're going to have to type this all into your calculator, we know, using our system of equations. So don't expand it if you don't need to.